In this particular chapter, we are going to talk about the air supply for the ventilation. Section 6.2 applies over here, that is air supply for the ventilation. It talks about the supply of conditioned air to the ventilated spaces such as those listed below shall be provided directly or by transfer of less vitiated air from an adjacent space, and shall be sufficient to permit the exhaust airflow required to be met. That means what it says that exhaust air to this particular areas can be taken from the adjacent spaces or by the exhaust fan, that is primary sanitary rooms. It includes bath, shower, urinal and WC, and laundry, changing rooms and cleaning lockers. In other words, it says that you don't have to directly take the air from this particular room, but whereas when you take out the room, the air transfer from the other rooms also you can consider. So this is what it all about talks. So let's go to the next session over here. This particular slide talks about the temperature of supply airflow. Let's go section 6.1. It talks about it's a volume of space. What it says as the volume of furniture, wardrobe, stationary equipment, etc. shall not be deducted in calculating the gross volume of cabins and other spaces. So as you know, when we calculate the ventilation air, there are certain air changes we need to consider. So when we need to consider the air changes, we need to calculate the volume of the room also. And when we calculate the volume of the room, there is always an argument that should we deduct the volume of the chair, should we deduct the volume of the furniture, should we deduct the volume of the bed and arrive at the airflow? No, it cannot be done. It is strictly mentioned in section 6.1 that you cannot deduct the volume of these stationary items. So you need to consider volume of a room as if it's an empty room. So section 6.3 here what talks about, it's the temperature of supply airflow. The temperature of air supplied to the space shall not be more than 10 degrees Celsius lower than the average temperature, nor the heating mode more than 15 degrees Celsius higher than the average temperature of the space. This means suppose your room condition or room temperature is 24 degrees Celsius or so let's say 27 degrees Celsius, then the difference between the supply air temperature should not be greater than 27 or 24 minus 10. Let us say an example of 24 degrees Celsius your indoor condition. So 24 minus 10 is equal to 14 degrees Celsius. So your supply temperature should not be more than 14 degrees Celsius. And suppose in the heating mode, it should not be more than, say example 24 plus is 39 degrees Celsius. 24 plus 15. So this is what it talks about. So hope this section is clear. They have given what is the supply temperature should be in winter as well as summer conditions, and the volume criteria also they have made it very clear over here. This particular section talks about the exhaust airflow for the marine accommodation spaces. The section 6.4 talks about the exhaust airflow, and these are the various areas which are listed which forms the part of a marine accommodation. Say for there are rooms like let's take a first one, that is saloon, mess room, dining room, common day rooms. Sorry. So the exhaust airflow from these rooms shall be same as supply airflow. And second one is your hospital, that is medic room, pantries and smoking rooms has to be at least 20% more than the supply airflow. The exhaust airflow should be 20% more than the supply airflow. And private sanitary rooms includes the bathroom, shower. The rate is 0.02 meter cube per second or minimum 10 air changes as per hour, whichever is higher. Then fourth is common sanitary rooms. It includes common means it is not a private one. It's not for only two people. It's for many people. They are using a sanitary rooms. For the common sanitary rooms, these sanitary rooms are near to the mess rooms where many people are eating and they just want to wash their hands and go for the shower or urinals or WC. For these are called as the common sanitary rooms. And for common sanitary rooms, laundries, drying rooms, iron rooms minimum 15 air changes per hour. Then you have changing room, janitor and cleaning lockers has to be exhaust airflow minimum 10 air changes per hour. Then you need to have the public sanitary rooms in passenger ships also 15 air changes or the rate which is already given in the table. So you need to clearly understand while calculating the exhaust airflow. This is very important table. So you need to understand while calculating the values of the exhaust airflow. So just mug up this table carefully before going to interview how many air changes for which areas. So this is going to certainly help you. Remember this is a part of ISO 7547. So take it very seriously and this is being commonly and frequently asked in the interview. So you should know it very perfectly. So mug it up properly. Now let's go to the next session. Now this particular slide is again the exhaust system. The section 6.4.2 exhaust system states that the exhaust system from the space listed below shall be directly fed to an open air and not used for the recirculation. Additionally, the exhaust air system for each of these spaces or group of the space shall be separate from each other. It says that suppose you are taking the exhaust from these spaces, it should be an independent exhaust. That means an exhaust fan should not be connected to any of these spaces except that those spaces. And what does it mean is I will just explain you. And one more thing is that none of the air which is supplied to these particular spaces should again come back to the recirculation. Uh, the hospital is medic room, sanitary room, laundry and pantry. These four spaces should have its own independent exhaust system, exhaust fans, one working, one standby. The reason is that because as you know medic rooms the contamination should not be there, so it should be negative pressurization. Then sanitary rooms, of course, the smell should not spread. The laundry, of course, because you have a lot of drying, then heating is getting generated. And again the pantry again for the obvious reasons. So these are the spaces where you need to have an independent exhaust fan, and these are the spaces where the air you should not take it back. Whatever air conditioning air you're supplying into this room, everything 100% you need to exhaust. Let's go to the next point. It is section 6.5 air balance. The system shall be positively balanced. It should be applicable on every deck. It means that the positive pressurization should be the part of the system and it is independent of this laundry and sanitary room and hospital where the negative pressurization you need to maintain. Then apart from these rooms you need to get the positive pressurization in short. And the rooms where these when the in the rooms where there is a one tumbler or dryer, the balance between the supply and exhaust should be considered. Okay, so every tumbler dryer as a manufacturer, it has a different requirement for the airflow. So while designing your exhaust system, you need to consider that what is the requirement for the tumbler dryer for that particular while designing the laundry system over here. There will be catalog over there which tumbler drive you are selecting. As per the catalog value you should select and match with the requirement of an exhaust fan, selection of exhaust fans. Then hospitals, galleys, food preparation areas, other rooms such as smoking rooms, etc. shall be maintained at slightly lower pressure than the adjoining spaces. Because as you know, food preparation, the smell comes out. The galley also, the kitchen, the smoke comes out. Or the smoking room, of course, the people smoke there for obvious reasons. So these are the spaces need not be positive pressurized. It should be slightly lesser pressure than the adjacent so that smoke or whatever smell or whatever it is, it should not travel from one area to another area. Rather it gets exhaust and the fresh air, it gets replenished by the fresh air. So these are few areas it has to be slightly negative pressure than respect to the other areas.